ordered pairs, when given ordered pairs examples. Today we're going to continue with the given equations. So for those, and you may have started those already, but if they're in slope-intercept form, you just have to look at the slope and compare them. So for these two, would these be parallel, perpendicular, or neither? Yes, because they're the same. For number 10, if we looked at these two slopes, would these be parallel, perpendicular? You don't have to write both, I'm just reminding you those are the symbols for parallel and perpendicular. Yeah, you can put the symbols or you can write it out, either or. For number 11, would those be parallel, perpendicular, or neither?
Neither.
Neither. They look the same. One is positive, one is negative. So the positive negative makes you think it's perpendicular, but they're not negative reciprocals, so this would be a neither. There's not a symbol for neither. You have to look that up. So if it's given in slope-intercept form, it's as easy as that. Look at the slope, compare them. If it's not in slope-intercept form, then you have to solve them. So like number 12, we have to get both of those in slope-intercept form and then compare them. So for this first one, you have to subtract x to the other side. You have 6y minus x or equals negative x plus 30. Divide everything by 6. We have negative 1/6x plus 5. The other equation is almost in slope-intercept form. We just have to divide everything out. So divide everything by 3 to get y equals 6x minus 2. Once we have them in slope-intercept form, then we can look at the slopes and see, are these parallel, perpendicular, or neither? We're going to do one more of these together, and then I'll let you try some. We're going to go to number 16. Remember that number 16 are your special cases. So you have a y equals and an x equals. You have to remember the types of slopes for those. For y equals 6, what type of slope will that be? For x equals -1. So looking at those two slopes, are they parallel, perpendicular, or neither? Even though they don't look like they're negative reciprocals, 0 and undefined are always negative reciprocal slopes. Do we have any questions on this? Anything we've done? Next 2 to 3 minutes, you may not need that time to go and do 13, 14, and 15. 13, one of them needs solved, 14, both of them do, and 15, they're both already in slope-intercept form. And then we'll come back and go over this. For those three, 13 was perpendicular. After you solve this one, you should have got a slope of 5. 14, they were parallel. After solving both, you should have got they both had a slope of 3. And 15 was perpendicular because 1 and -1 are negative reciprocals. Questions on any of those three? On to the next page. So there's like two parts to this. One is, are you able to see if two lines are parallel or perpendicular in either? The other part is kind of what we were doing in the last unit, writing the equations, but with a twist, because now we're going to be writing equations that are parallel or perpendicular to another equation. So filling this out really fast, this is just to remind you that parallel lines have the same slope, and perpendicular lines have negative reciprocal slopes. So what's going to happen in these is we're going to be given some equation in order to see if these lines are parallel, perpendicular, whatever. We have to have two of them. So they're giving us one of them. We have to find the equation of the other. And they're going to give us a point that goes through whatever the other one is. And we're going to write the equation of the line. So it's kind of going to be like when we were given a slope and a point and had to find the equation of a line. It's a little better. For number one, they give us a point. They tell us we have to write an equation that is parallel to the one that's given, and they give us an equation. So we first have to know, since it's a parallel line, or the one we're going to find is going to be parallel, the slope of our new line is going to be the same. So I would write that off to the side, that way you know that. And then once you know what your slope is, you have a point, you have a slope, and you're going to use your point slope to find this new equation. So that's not going away. We are going to use it quite a bit. So I would put my point and my slope in y minus 7 equals my slope is -4 times x minus my x1, which is -2. And then start solving from there. I would simplify this before you distribute, that way your signs don't get messed up. And then after you distribute, you get y minus 1. So add 7 to the 5. Y equals -4x minus 1 is our new equation that is parallel to our original equation. The slopes are the same, but the y-intercepts are different. That's how we know that we have two parallel lines. If the y-intercepts were the same, we would have the same one, and it would be parallel. Number 2 is similar, except it's not in slope-intercept form, so we have to solve that first. to see what our slope is, let's solve this, get this in slope-intercept form first. X to the other side. We have negative 3y equals negative x plus 9. Divide everything by negative 3. So we have the equation y equals 1/3 x minus 3. Now, that doesn't answer our question or the problem. We just redid that example. So after we do that, now we know that our other equation that we actually have to find, because it has to be parallel to this one, it has to have the same slope. It has to have that slope of 1/3. Once we find that slope, then everything else is the same. The starting process is different. And again, we're going to use that point slope formula. Y minus negative 1 equals 1/3 times x minus 3. And so on. Again, simplified. In this case, you can simplify and to the same time. And then get y by itself. So I subtract 1 to the side. So our new equation, or the one that's parallel to the original, is that y equals 1/3 x minus 2. Some of you are still but do we have any questions on that process or anything about those two? Perpendicular examples, and then I'm going to let you guys have it. So the concept is really the same for perpendicular, but it's a little different. Because with perpendicular lines, the slopes have to be negative reciprocal, so before you do anything, you have to think of what would the negative reciprocal slope of this be. Negative 1/2. You have to do that first, otherwise everything else gets done wrong. But once you have that piece, then the process is the same. Put that and your point into the point slope formula. Y minus 3 equals negative 1/2 times x minus 4 and keep going. Continue, get y by itself. And after that, you should get the equation y equals negative 1/2 x plus 5. For these two equations, the slope just needs to be a negative reciprocal. The y-intercept could be the same, could be different. That doesn't really matter. questions on that process? And then the last example we're going to do is another perpendicular one, but this one is now in standard form. You have to convert it before we solve it. So same process, but with an additional step. Subtract 5x on both sides. And you're left with y equals negative 5x minus 21. Divide everything by positive 3. This is your original equation, not our final answer. So we need this to be perpendicular. What slope would be perpendicular to negative 5/3? If you don't do that additional step, solve it, and then change the slope, you'll end up with either the same slope or the wrong slope. And then use that slope and that point to put it back into your pencil times x minus 9. And after you solve it, you should get the equation y equals 3 plus x plus 4. So that process is probably the most you'll have to do with parallel perpendicular lines if you have a perpendicular equation and it's not in slope-intercept form. Before I let you guys practice, do you have any questions? For the remainder class, the last page has 8 problems. 4 are specifically parallel, 4 are specifically perpendicular. Make sure you pay attention to that. And I want you working through that. Ask questions if you get stuck or aren't sure, or just want me to check it. I'll be around.